Hi, welcome back to another junior measurement video. We're going to chat about volume of composite shapes. Now, the volume is the amount of space inside a 3D object. When two or more 3D shapes are placed together, we have to find the total volume of each separate shape. So imagine some of these examples. These are all called composite shapes because they have all got two or more 3D shapes placed together. All right, so to find the volume of a composite shape, we basically break it up into smaller shapes that we can deal with. So let's calculate the volume of the following shape. I'm going to put a line across here and create a cuboid on the top and a cuboid on the bottom, shape 1 and 2. So let's start with the shape on the top, cuboid 1. Volume is base times height times depth. So the base is 5, the height is 4, and the depth is 3. So we're just going to go 5 times 4 times 3, and that gives us 60 centimeters cubed. Cool, let's move on to cuboid 2, the cuboid on the bottom, which has base times height times depth as the volume. So the base is 12, the height's 4, and the depth's 3. So we're just going to go 12 times 4 times 3. That gives us a volume of 144 centimeters cubed. So now we can just add up the two volumes to get the total volume of that composite shape. So 60 plus 144 gives us a total volume of 204 centimeters cubed. Awesome, let's push on to example 2. Estimate the volume of this beach changing room. So we've got enough dimensions given to estimate the volume. So let's start with the cuboid at the bottom, which is the main box of the changing room. We know the volume is base times height times depth. So we've got a base of 1.8, a height of 2.5, and a depth of 1.4. We then multiply those to get a volume of 6.3 meters cubed. That's the cuboid. Now let's turn our attention to the triangular prism at the top, the roof. Now, the volume of a triangular prism is area of cross-section times depth. Now, the cross-section is this triangle bit at the front here. So we're going to go base times height divide 2. That's the area of a triangle. And then we've got to times it by the depth. So the base of the triangle is 1.8 meters. The height of the triangle is 0.6. If you can see, the height of the roof is 0.6. We're going to go 1.8 times 0.6 divide 2. That's the cross section. And then we have to multiply it by the depth. The depth is 1.4. So if I multiply all that together, I get a volume of 0.756 meters cubed for my roof, for the triangular prism at the top. And now I can just add the two volumes together, the 6.3 and the 0.756, to get 7.056 meters cubed, which is the area of the volume of the changing room. Right, last example to finish off with is how do we find the volume of the following shape? This is basically a cylinder with a second cylinder drilled out of the middle. So basically what we're going to do is work out the volume of the large cylinder, work out the volume of the small cylinder, and do a subtraction because we've drilled out that small section and taken that middle bit away. So here are all the dimensions we need. So let's get into the small cylinder. The volume of a cylinder is pi times radius squared times height. So pi times 80 squared times 40, that gives us 804,247.7 millimeters cubed. I've rounded my answer to 1 decimal place. Right, move on to the large cylinder. The volume of a cylinder is pi times radius squared times h, which is pi times 100, because that's the radius of the large cylinder, squared times 40, and that gives me 1,256,637.1. Now I just need to subtract everything because I've taken the small cylinder away from the large. So if I do a subtraction, I get a final answer, which is 452,389.4 millimeters cubed. That is the volume of the remaining shape. Cool. Thanks so much for watching.